Okay, so for problem 55 of homework 5.3.2, it says that a population of 8 beavers have been introduced into a new wetlands area. Biologists estimate the maximum population the wetlands can sustain is 60 beavers. After 3 years, the population has 15 beavers. According to a Gomp, according to the Gompert's growth model, how many beavers will be present in the wetlands after 10 years. So let's just get the points here. When the time is 0, we got, let's let y equal how many beavers there are. We got about 8 beavers. And then, time equals 0. And then when the time is 3, after 3 years on there, it says that we got 15 beavers. And so we're trying to find when time is when time is 10, how many beavers are there? So by using the Gompert's equation rule, we do y equals the maximum number there can be. In this case, it's 60 times e to the power negative c e to the power negative k t. And the first thing we need to do is to get rid of this k and solve for c. So we plug in the 0 and 8 into this. So we got 8 equals 60 e negative c e, and then 0, which is t, 0 times negative k is just 0, so 0. Alright, and then after this, we do 8 over 60, which equals e to the negative c e to the power 0. And then after that, we do the natural log of this right here. And 8 over 60 is about 1.33 repeating. So 1.33 repeating equals the natural log of e to the negative c e to the power 0, like that. And that should give us negative 2.015 right here. And c to the e to the power of 0 is just 1. So 1 times negative c is just negative c. So we've just got negative c right there. And then because it's negative c, we just change the sign over here to get the c. So c equals 2.015. And then for the next step, now we need to solve for k, right? So we plug in everything into we use this equation right here, and we plug in c, and we use the t equals 3 and the y equals 15. So now we got 15 equals 60 e to the negative 2.015 e to the negative k times 3. And so the first step, we divide everything by 60, and that'll get us down to 0.25 equals negative 2.015 e to the negative k times 3. And then after that, we take the natural log of both sides of this equation to get this e away. So we got the natural log of 0.225 is negative 1.3863, about that. And that equals to negative 2.015 e to the power negative k times 3. And then we divide these two numbers. We divide this number, negative 2.015, divide that by negative 1.3863. So this is on top, this is on bottom. And then that'll give us 0.688 about. And that equals e to negative k over 3. Then we take the natural log of both of these to get the negative k over 3, times 3, not over 3, times 3 down. And that'll give us negative 0.374 equals negative k times 3. And then we divide by 3, and that'll get us, we divide by 3 and then change the sign to positive. So that'll give us about 1.1247 equals k. And now we plug this all into our equation, and instead of plugging in y and x, we just plug in 10 for the time and solve for y. So we do y equals 60 e to the negative 2.015 e to the negative 1.247 times 10. So negative 1.247 times 10 is negative 1.247. That decimal should be out there. And then so we'll get this next. 60 e negative 2.015. Whoops, so 2.015 e to the power of negative 1.247, and then e to the power of negative 1.247 is about 0.287. So then we got y equals 60 e to the negative 2.015 times 0.287, and then you multiply those numbers together and you'll get about negative 0.5793. 60 e negative 0.5793, and then e to the power of negative 0.5793 is about 0.56. And we multiply these together, y should equal about, rounding up, 34. So our final answer is we'll have 34 beavers.